class. This class is for class 9 and chapter that we are discussing is rectilinear figures, and in this we are discussing exercise 13.1 and we are following the textbook ML Agarwal. In the previous class we have done up to question number 13, so now we are starting with question number 14, A part. Now what is given in question number 14 is, in the figure given below, ABCD is a parallelogram, X is the midpoint of BC, line AX produced meets DC produced at Q, parallelogram ABPQ is completed, prove that triangle ABX is congruent to triangle QCX and DC is equal to CQ is equal to QP. What do they say? There is a parallelogram ABCD and another parallelogram ABPQ, and X, this point X is the midpoint of BC. It means it is given that BX is equal to CX. First thing we have to prove, triangle ABX and triangle QCX. ABX and QCX are congruent. So first we will take in triangles ABX and QCX. What do we find in these two triangles? First thing, you can say that BX is equal to CX, given. It is given that X is midpoint of BC, so BX is equal to CX. That is what we have written, number one. Second thing, you can say that ABX, in triangle ABX we can say angle AXB is equal to angle QXC. Why? Because they are vertically opposite angles. This angle and this angle are vertically opposite angles, so they will be equal. Third point, we can say that angle ABX is equal to angle QCX. Why? Alternate interior angles. We can say that this angle C and this angle B, because AB and CQ, because DC and AB are opposite sides of parallelogram, so DC is parallel to AB. If DC is parallel to AB, then extended part of DC is DQ, or you can say CQ is parallel to AB. AB and CQ are parallel and a transversal BC is intersecting them. So this angle C and angle B will act as alternate interior angles. Something like this is the figure. So we have proved with the help of angle side angle and angle side angle, we have proved that triangle ABX is congruent to triangle QCX by which rule? Angle side angle rule. This was the first part. Now in the second part they say prove that DC is equal to CQ is equal to QP. So ABCD is a parallelogram. So we can say that AB is equal to DC since they are opposite sides of parallelogram, and we know that opposite sides of parallelogram are parallel and equal. So AB and DC are equal. Similarly, we can say that AB is equal to QP, again the same reason, opposite sides of parallelogram. Which parallelogram? ABPQ. It is given that ABCD and ABPQ are parallelogram. So first we have taken ABCD, in this CD and AB are equal, and then it is given that ABPQ, so ABPQ, QP and AB are equal. So QP and AB are equal, AB and DC are equal. Now we have also proved, here we have proved that triangle ABX and QCX are congruent. So we can say that AB is equal to CQ. Which reason? CPCT. If triangle 1 and triangle 2 are congruent, all the 6 elements of first triangle are equal to the corresponding 6 elements of second triangle. So we can say that AB is equal to CQ. Now AB is equal to CQ, AB is equal to DC, and AB is equal to QP. So let's say this is equation number 1, this is equation number 2, and this is equation number 3. So we can say from equations 1, 2 and 3 we get, what do we get? Here we can say AB is equal to CQ, here we can say AB is equal to DC, here we can say AB is equal to QP. It means CQ, DC and QP are all equal. So we can write the final statement as CQ is equal to DC or CD, DC is equal to QP, and that is proved. This was the second part that has been proved. So now we move on to the second part of this question, 14th B part. Now question number 14B part, they say in the given figure ABCD is a parallelogram and AP and CQ are equal, and we have to prove that AC and PQ bisect each other. This is AC and PQ. Let us say that they intersect each other at point X or M. Let us say that these lines intersect each other at M. It means we have to prove that AM is equal to CM, and we have to prove that PM is equal to QM. This is what we have to prove. AC and PQ bisect each other means both these lines where they intersect, that is the midpoint of both the lines. It means this AM must be equal to CM and this QM must be equal to PM. So I have taken a point M where these two intersect. Now if we consider the triangle 1 and triangle 2, we will see, let's say in triangle MAP and triangle MCQ. In these two triangles, first point, what we can say, AP is equal to QC because it is given. First point, AP and CQ are equal, so AP and CQ are equal, it is given. Second point, we can say that angle AMP is equal to angle CMQ. Why? These are vertically opposite angles. AMP is this angle and QMC is this angle. These are equal vertically opposite angles. Third point, we know that DC is parallel to AB since ABCD is a parallelogram, and this is DC, this is AB, and a transversal QP is intersecting them. It means this angle and this angle, means this angle and this angle will be considered as alternate interior angle and they will be equal. So we can say angle APM is equal to angle CQM. Why? Because they are alternate interior angles. Now angle side, angle side. So these two triangles MAP is congruent to triangle MCQ by angle side rule. When the triangles are congruent, it means all the 6 elements of first triangle is equal to the corresponding 6 elements of other triangle. It means AM will be equal to CM, implies that AM is equal to CM by CPCT. At the same time, PM is equal to QM. At the same time, PM is equal to QM by CPCT, and that is your proof. Hence proved. So this is the second part of question number 14. Now we move on to question number 15. Now question number 15. In question number 15 they say that ABCD is a square, so we have made a square. And they say that point P is on BC and there is a point Q on AB such that AP and DQ, AP is joined and DQ is joined, and AP and DQ are equal. These two things are given. We have to prove that AP and DQ are perpendicular to each other. Means this angle 90, this angle 90, this angle 90, this angle 90. It means if we prove any of one angle is 90, it means our job is done. So let us name it as point X. Let us say this is point X where these two lines DQ and AP are meeting. I will read out the question. They say ABCD is a square. A is joined to a point P on BC. A is joined to a point P on BC and D is joined to a point Q. D is joined to a point Q on AB such that AP and DQ are equal. So AP and DQ are equal. Then prove that AP and DQ are perpendicular. We have to prove that these two lines are perpendicular to each other. So we have taken this point of intersection of AP and DQ as X. Now what we can do, first of all we will take two triangles. In triangle DAQ and triangle ABP. In DAQ, DA is equal to AB because sides of a square, and we know that sides of square are equal. Then in triangle DAP we can say angle A, and in triangle ABP we can say is equal to angle B is equal to 90 degree because these are angles of a square. Angles of a square. Third thing we can say that in DAQ, DQ and in ABP, AP, these are equal because it is given. It is given that AP is equal to DQ. Let us draw these two triangles which have been written here separately. So one triangle is something like this. That is DAQ. And other triangle is something like this. This is ABP. Now, in these two triangles, first thing is DA is equal to AB. Second thing is angle A is equal to angle B. Third thing is DQ is equal to AP. So, right angle hypotenuse side, right angle hypotenuse side. We can say that triangle DAQ is congruent to triangle ABP by which rule? RHS. RHS stands for right angle hypotenuse side, and that is applicable in right angle triangle. So these two triangles are congruent. If these two triangles are congruent, it means all the 6 elements of first triangle are equal to the 6 elements of other triangle. Let us say that this, so therefore this angle will be equal to this angle. Let us say this angle as X. It means we can say that angle ADQ, that is this D angle, is equal to angle PAB. PAB means this angle. This angle and this angle are equal. Why they are equal? By, let us say, is equal to X, and I am writing let, means we have assumed their value as X, and why are they equal? By CPCT. Now, this angle is X, and at the same time this angle is also X. Total angle A is 90 degree. So this left part, this part will be 90 minus X. Why 90 minus X? Because this total angle is 90, this total angle is 90, and this is X, so this will be 90 minus X. It means I can say that angle DAX will be angle A minus X. Angle A is 90 minus X. We got angle DAX as 90 minus X, and this is the most important part of the question. Why? Because now we can say that if we consider triangle AXD, we are writing in triangle AXD, we know that sum of all the angles of the triangle are equal to 180 degree by angle sum property. So we can say angle DAX, that is angle A, plus angle AXD, that is angle X, plus angle XDA, plus angle XDA is equal to 180 degree by which property? Angle sum property. Now angle DAX, that is angle A, this is given to you as 90 minus X. So this we have calculated. Angle DAX is equal to 90 minus X, plus angle AXD we have to find out. Angle AXD and plus angle XDA. Angle XDA we have already assumed X. You can see this angle D, ADQ. ADQ either you say or you say ADX. So this is equal to X, is equal to 180 degree. So angle AXD will be 180 minus, this goes to that side, becomes minus X, and this also goes to that side, minus 90 minus X. When you open the bracket, it will be 180 minus X minus 90 and plus X. Plus X and minus X will cancel. 180 minus 90 is 90 degree. Angle AXD is equal to 90. Means this angle we have calculated 90 degree. If this is 90, then this has to be 90 because it's a straight line. If this is 90, this has to be 90 because this is a straight line. If this is 90, then obviously this is 90. So all the angles are 90 degree. So we can say one more line. Therefore AP is perpendicular to DQ. Hence AP and DQ are perpendicular to each other, and that is proof. That is your proof. So this is question number 15. Now we move on to next question, that is question number 16. Now question number 16, they say that if P and Q are the points of trisection of the diagonal DB of parallelogram ABCD. So this is the diagonal DB and P and Q are the points of trisection, means these 2 points P and Q divide the diagonal DB into 3 equal parts. So what I have written in the given portion, I have written ABCD is a parallelogram, that is given, so ABCD is a parallelogram. Second point, DP is equal to PQ is equal to QB. DP is equal to PQ is equal to QB, and I have taken them as X. Let us say this portion is X, this portion is X, and this portion is X units long. Means that P and Q are dividing the diagonal DB into 3 equal parts, and I have assumed that length of each part is X units. So DP is equal to PQ is equal to QB. We have to prove that AP is parallel to CQ. Let's see what we'll do. So first of all, we will say, we'll write proof. In proof, we will try to take the 2 triangles. So in triangle APB and triangle CDQ. I am drawing these triangles separately so that you may understand it much better. This is A, P and B, and the other triangle is something like this. Q, this is Q, C and D. Now DQ length is 2x. It is 2x. Similarly, PB is also 2x. PB is also 2x, number 1. So in triangle APB, we can say PB is equal to DQ. DQ. Why? Same length. And why same length? That has been explained. X and X is 2x and this X and X is 2x. So these two sides are equal. PB and DQ are equal. So that is why it is written PB and DQ is equal. Then we can say that this angle CDQ and angle DBA will be equal because these are two parallel lines, AB and CD, and a transversal is cutting them. So this angle and this angle will act as alternate interior angles. So we can say angle CD, let's say P. CDP is equal to angle QBA. QBA, because they are alternate interior angles. Third point, we can say that AB and DC are equal because AB and DC are opposite sides of parallelogram. So we can say that AB is equal to CD. Since ABCD is a parallelogram, you can also write opposite sides of parallelogram are equal and parallel. So AB and DC are equal. Now AB and DC are equal. So this angle and this angle was proved equal. So by side angle side, we can say that triangle APB is congruent to triangle CDQ by side angle side rule. Now when the triangles are equal, we know that all the corresponding elements, all the 6 elements of first triangle are equal to the corresponding elements of second triangle. So we can say this angle P will be equal to angle Q. So we can say angle APB is equal to angle CQD by CPCT. Now if you look at this angle and this angle, these two angles are equal, but these two angles can also be considered as alternate interior angles since they are equal. Means this is a line and this is a line and a transversal is cutting something like this, and we are saying that this angle and this angle are equal. They are equal, so they can be termed as alternate interior angle, and therefore AP and say can be termed as, we can say termed as alternate interior angles. Therefore AP is parallel to CQ. That is your proof. This point is very important. If you are clear with your concept of parallel lines that you have studied in class 7 and 8, then this is very clear to you. Otherwise you need to brush up once what are parallel lines and what are the angles related to them are equal and when are they not equal. All the conditions I mean to say. So this we have done with question number 16. Now let's see if we can continue with the 17th question. So now there are more questions. So the other questions will be continued in the next class, and I expect everybody to practice all these questions of proving at least 2 times by your own after watching the video. So stay blessed and stay healthy. Thank you all of you.